team member, I'm a reporter Wang Xuezhen, and my team member Zhang Yuchang, Zhong Wanyu, Yu Yanting, and Zhou Tingwei. Thank you.
Good afternoon, ladies and gentlemen. This is my captain, Zhang Yibin. This is my teammates, Lan Jiawenjing, teammates Guan Jingzi, and this is Ding Chongfeng. I'm Shi Kai. We come from Beijing Memorial University. Thank you.
Now, let me introduce myself. I'm Xian Zhonggao from National Normal University, and this is Professor Luo Fangyu, also from National Taiwan University. Professor Liu Songfen from Nankai University. Professor Wang Yinglong from Nanjing University. So now, according to the schedule, I think it's Team A to do a presentation for 10 minutes. Right. So.
Good afternoon, every viewers. We are come from the Department of Physical Science Military Academy. I'm a reporter Wang Xuezhen. And our topic is Boiled egg. This is our outline. We have including 5 parts. Question. Suggest that the non-invasive method to detect the degree to which egg was cooked by boiling water. Investigate the sensitivity of your method. It means don't break the eggshell and realize the maturity of eggs. We researched this information from the science of cooking, and it shows us the protein becomes sticky at 16 degrees and lost the mobility at 18 degrees. The yolk lost the mobility at 65 degrees, solidify quickly at 17 degrees, and we can make the golden egg. The golden egg is hard protein, soft yolk, and in a 100-degree water, cooking for 5 minutes and cooling. We use the transparency to identify the maturity of the egg because the light in different media have different transparency. Design. This is our equipment. We have electronic debra, induction cooker, stainless steel pot, temperature laser gun, thermostat skin, grid lasers and aperture, and a box. First, we control the egg weight in 63 grams. Use the electronic debra and boil the water to 100 degrees. Hang the eggs in the water. Put the eggs into the water of 5 degrees for 20 minutes. And finally measure an egg in a box. We put the eggs in the water of 5 degrees for 20 minutes. We need to cooling the egg because it has some residual temperature. And we use the temperature laser gun to test the temperature and take the photo immediately. Okay, issue. After being boiled, does the residual temperature of the egg affect the egg cook? How to find a relationship between heating time and maturity? And how to define egg maturity? We make a plot because we don't know if the transparency will be affected by residual temperature. And we cook the egg in boiling water for 6 minutes. And the black point is after we cook the egg, and we put it under the room temperature for 20 minutes. White point is the same step, but we put it under the 5-degree water cooling for 20 minutes. And we can see the difference in the egg transparency is different. So we can know the residual temperature will affect the egg maturity. So if we don't take it away. With the temperature raising, foreground will get more and more small because the egg whites and yolk is getting hard. The light cannot through it. And we cut the egg to see what stay to inside because we don't know if we heat the egg for several minutes, what stay to inside. So we cut it now. Before we define the maturity, first we have to know the relationship between heating time and the transparency. When the time increases, the transparency will decrease because the egg is cooked. And this is the ratio of the light transparency length. How to define the egg maturity? After several experiments, we found we can see the 3 stages of our experiment. The first stage is the soft boiled, and the second stage is the medium boiled, and the third stage is the hard boiled. And O minus transparency length is the maturity. And we also calculated the formula with the slope. And this is our definition of the product. When the heating time is 0 to 3 minutes, we will know the protein is soft and the yolk is soft. But now the protein is getting solid. When the heating time in a 3 to 6.4 minutes, we will know the protein will become hard and the yolk still soft. But now yolk is getting solid. When the heating time over the 6.4 minutes, the protein and yolk both getting hard. So we will know we make the conclusion that the residual temperature will affect the maturity of eggs if we don't remove it. And the empirical equation was delivered as above this formula. And the light transparency and maturity of eggs will show the different stage. As we see, the first stage is protein getting solid, and the second stage is the yolk getting solid, and the final stage is the yolk getting hard. And thank you for listening.
Now let's hear it from B.
I'm Shikai from Beijing Normal University. I'm going to report my study about problem boiled egg. This problem asks us to suggest some non-invasive methods to detect to what degree an egg is cooked by boiling and to investigate the sensitivity of the method. Here are 3 keywords. First, non-invasive, and it means the egg must be still edible, and the shell must be finally complete. And boiling, it means you must use the water that's near 100 centigrade because the sea level is almost here. And make sure all the content, and this boiling water will make sure all the content finally solidify. Third, sensitivity. You must know how much will the response variable change when your cooked degree change 1 unit. I've divided my report in 5 parts. First, what's cooked, and how to describe cooked degree, and to wait to know the cooked degree without breaking the shell, and finally give a summary. First, what's cooked? When we boil eggs, phase transition will happen to proteins and fats in the egg. As you can see, the structure of the proteins will be broken, and keep boiling, it will change into molecules, and it will put together and become little aggregates. And that's why the egg white and egg yellow become solidify and become acidic, and you can eat it. So, phase transition is the essence. As you can see, it requires about 20 seconds for the protein to complete the reaction when it reaches 90 centigrade. And so for every voxel in the egg, when it reaches 90 centigrade, after 20 seconds, it will finish the transition. And because we use boiling water, which means the water temperature is almost the same, so the temperature distribution can be used to represent the whole phase transition distribution, like this. And here we define the phase transition distribution of the egg, the cooked degree, and use temperature distribution to represent it. And now we are going to get this representer, the temperature distribution. We give this heat transfer equation and place into spherical coordinates, and this is Laplace operator. Solving it, we get how the temperature distribution changes with time. But there's a problem, we can't detect the whole distribution of the egg. It means we must need another representative. And core temperature can be a good one, because it only includes one variable, the boiling time, and rule out the other one, the position of the voxel. This center is, as you can see, it's in the geometry center. Here, let's get the core temperature. First, we approximate the egg to an ellipsoid, and the second time approximate to a sphere to simplify our calculation. And the Laplace operator becomes this, and the equation becomes this. The boundary condition, the initial condition is here, and here are the parameters. Solving it, we get this result, and setting out to 0, we get how the core temperature changes with time. As we have done the approximation, some error will come. Now we're going to roll it out. Look at lambda. It includes one parameter, it's GS. This is the specific area of the sphere, which use the surface area of the sphere to divide its volume. And if we replace the sphere's specific area with the ellipsoid, like that means we use GP to replace GS, we will eliminate most of the error. As you can see, the change is, there's not much difference between the ellipsoid and this sphere if we do this to eliminate the error. Now, we have get the relationship between core temperature and boiling time, and we have looking for all the parameters we need from references, so we can plot how the core temperature change with the boiling time. But is this result reliable? We do some experiments, and this is our device. As you can see, at that place we make the egg suspended in the water. We put the experimental results and the theoretical curve together, and we have altered the parameters because in the eggs in the references and the eggs we use are not the same. After the correction, now we can use this curve to predict the time we use when we need to boil the egg to some certain core temperature. Now we can control the core temperature. It means we can control this representative and to control the cooked degree. But we must know the core temperature without breaking the shell. It means we must find some special response variables to know it. And the first thing we have is light. And in factories, they use light intensity attenuation to define the quality of food. Here we use log I over I0, and I will explain it later. And looking up some references, when you rotate the egg, some dynamics parameters may also be useful, such as moment of inertia or damping coefficient. Let's start with dynamics method. We use capstone to get the parameters of the egg, and when we put the egg on it and rotate it, and we can get all the parameters we need. This is the damping coefficient, and this is the moment of inertia. We plotted how it changed with the core temperature. As you can see, when the core temperature reaches 55 centigrade, it's a real mass. But when the core temperature is lower than 55 centigrade, it's almost linear. Still, it can be useful, but this range is too limited. So we abandoned this method, and let's talk about optics. First, I want to explain why will light attenuation happen. Before the phase transition, proteins will dissolve in the water, and at this time, before its structure broken, the light can go through the proteins. But when you heat it, the little aggregates will come, like this one. It will reflect the light, so not all the light can go through. Here comes the light attenuation. We define I as the light intensity of the light that's going through the egg, and I0, the light intensity of the light that's coming, which means the light source. And we use A to represent the cooked dairy of the egg. And this is a device. We use this detector to get I and I0. When we boil our eggs, first time we put all eggs small ends up like this, and the second time put all eggs big ends up like this, and we get two formulas and two plots. Now, if we define 39 centigrade cooked degree 0 and 85 centigrade cooked degree 100, we can get the relationship between cooked degree and log I over I0. SEA means small ends up and BEA means big ends up. Now we do some experiments to testify our formula. As you can see, our formula is more precise when the cooked degree is lower, which means the light intensity is bigger. Let's now time to talk about sensitivity. Due to our definition of sensitivity, as you can see, the sensitivity is better when I is bigger, which means the cooked degree is lower, and it grows up rapidly. This is a log. And when we do experiments, we don't put all the eggs suspended in the water. Sometimes the egg will touch the bottom, sometimes won't. But since this won't make any difference because the light intensity of the light that touch the bottom and that not are almost the same. It means only a little of the shell will contact the bottom, and it will make no difference to our heat transfer equation. Now let's give a summary. First, we define what's cooked. Cooked is phase transition, and the cooked degree here is the phase transition distribution of egg. And we use core temperature to represent it, and use log I over I0 to get the core temperature without breaking the shell of the egg. And we give these two formulas. SEA means small ends up and big ends up. And we get its sensitivity, and the sensitivity is better when the light intensity is bigger. And here are the eggs we have boiled. References. Thank you.
So you both have 2 minutes to prepare for the discussion. And then Team B will first ask some short question to Team A, then followed by the other.
do you use this? Are the size of the eggs are all the same when you do your experiments?
Yes.
Okay. So for different size of eggs, boiling the same time, do you think the maturity is the same or not?
I think it is. I think it is the same.
Okay, we may because okay later. So I want to know what's your definition of cooked degree of the egg, or to say maturity of the egg.
It's good.
Boiling time, or the characteristic. Which one?
Could you please say it again?
What's your definition of cooked or uncooked? Okay. You use some method to detect these characters to know an egg is boiled, is cooked or not, right?
Yes.
Oh yes. Okay, understand. So, do you use laser gun to get the temperature of the shell of the egg, right?
Yes.
Okay. Also, do you think when it's cooling, is the egg getting more? Is the maturity of the egg still grows up?
After we're cooling.
When it was cooling.
Residual temperature. we will drop out the residual temperature after we cool.
Pardon? Pardon? Okay. Oh, that's all.
Thank you.
Okay.
So now from team A to team B.
Page 13.
13. Stop, please.
Okay. How to get your formula? I don't understand how to get your formula.
That heat transfer equation, and 13. We just give the how the heat transfer in the egg, and give the boundary and give the boundary condition and the initial condition. We can solve it and get the result. When setting up to 0, we get how the core temperature change with time, and all parameters are given. We can give this formula.
Did you try any other way to make the experiment?
We do some calculation to get this, not by experiments.
Thirteen.
Oh, this is 13. Yes.
30.
30. Oh,
30.
Oh, okay.
The circle.
Circle.
I don't understand it.
This. We get how the we know the relationship between cook degree and we boil different eggs and of different cook temperature and get the log I over I0 of it. So we can plot how the log I over I0 change with core temperature, and its fitting formula is this 2-1.
Thank you.
Okay, now you have 2 minutes to prepare for the discussion, which will last for 8 minutes. begin to discuss the difference that you have.
First, I don't quite understand, what do you think is cooked or uncooked? Obviously, when the maturity is grow up, what will happen in the egg? You say that the characters and of your boiling time is all the representative, but it's not the final essence. So I want to know if you ever consider it.
I know. So we cut the egg to see what's stated inside.
Do you mean that your definition of cooked degree is just these characters, right?
Yes.
Oh yeah, understand. Different cooked eggs have different characters. Understand. And it's related to the boiling time, right?
Yes.
Yeah. See. And I think as I'm concerned, when your character changes, the thing happens in the egg phase transition, and it may explain why these characters will change. As you can see, the transparency is getting worse, and it becomes oblique. This is because of the transition, because structure of the eggs are broken. Yeah, and become yeah. So, do you think why the egg will reflect the light, or to say it becomes oblique? Whether how do you detect the decrease of the transparency?
We put the egg in a dark box and darkening box, and we use a laser gun, temperature laser gun to hit on the egg, and we close the box. Use the camera to take photo, and we can see this picture.
What does this picture mean? What do you picture? I don't quite understand.
The raw egg transparency is full.
Oh yeah.
And when the time increase, the transparency will become more decreased because the egg is being cooked. The protein and the yolk is getting hot, so the light cannot throw it.
What camera do you use? Why it can get this result? That's a red light or something else? Red laser?
Yes, we use a red laser and capture. And we will hit the laser on the egg.
Oh yeah, I understand.
So the egg.
Oh.
So transparency is red.
Oh yeah. I think your transparency is the same as my log over I0. Only the difference is the light source is different because you use a laser, and the light goes through the egg, right?
Yes.
Oh yeah, and you put the camera to detect this, and I detect the light intensity of the light. That's I.
Oh, I see.
Could
I want to see you page 19.
Oh. I'm sorry about it.
That's okay. Take it.
Oh. Okay. Yeah. Next.
Because you speak too fast, I can't understand. Can you speak it again?
We use capstone to get the damping coefficient of the eggs that have different core temperature, and no, I need the attention. Yeah. This is the damping coefficient. When the rotator is stopped, it will tell us how fast it stop process, and momentum of inertia, which means when you rotate the momentum inertia is the difficulty you rotate it, and we plot these two coefficients with core temperature.
But you only core temperature, but you know the protein and the yolk, the maturity is different.
In fact, as I said, that we use core temperature to represent the temperature distribution and to represent the phase transition distribution of the egg. So with the core temperature, we can know the phase transition distribution, which means the cooked degree of the egg. I want to explain why it's a myth. Because when the as this shown, when the transparency is getting down, the force in the eggs are getting bigger, and when the core temperature reaches 55 centigrades, the force is almost the same. So it's not the same, but it's the difference is quite mass. So we can detect a linear relationship, but when the temperature is lower, we can get a linear relationship almost. Yeah.
But I think your way is not so identify with my way, you know. Not easy to see the sensitivity.
Oh, sensitivity.
Than my way.
And because this method is the range is limited, so we abandon this method. But before 55 centigrades, we can explain it. We investigate the sensitivity of our optics method.
I want to know what is your design? Like us. Did you have process?
Yes, of course.
I want to know your equivalent.
Which one? The dynamics one or the optics one?
Optics.
Yeah. As you can see, these are devices, and this is the detector, light source, and the foam board to keep out the lights, and this is the foam board too. And first, we don't put the egg in it and put the foam board on, and we can use this detector to get the light intensity, and like this. Now we can get the light intensity of I0, which means we don't put the egg in it, and the second time we put the egg in it and get the light intensity.
So you use the two ways.
Two times. One egg 2 times. Yeah. Maybe do you think can you use the this camera to do some improvement in my experiment?
This camera.
Yeah. What's it?
It's just a video player.
Video player. Okay.
No, not a video player. It's a camera. Just a camera. It just can take photo only and record the video.
Okay, thank you.
Okay, let's start here. You have 3 minutes to summarize do summary for 2 teams. So starting with team B. Okay, so 3 minutes for the preparation.
Okay, so please start. Thank you. First advantage. I think his experiment is more visual and it's pretty beautiful. We can see how the camera change with the boiling time, and we can discuss some problems to improve the cooked degree, how to define it, and a disadvantage. He leaves the consideration about the difference between the core and the surface, because the temperature of the surface includes two variations, and it may make some difference, and it doesn't explain the method he detected, how to detect the goodie without breaking the shell, and I don't think I know the insensitivity of his method. Let's give a summary. First, we have discussed what's the truth of codes. When the characters change with boiling time, the essence is phase transition. So I think we can, in fact, for different foods, the maturity is different, because for beef and for eggs. So, but one thing will happen. It's the same. It's a phase transition, and we have discussed some detailed ways, or to use light intensity attenuation, or to use camera to picture the how the picture of the egg change. But finally, I think we have got what's true cooked, and I think that's the most important thing. Okay, thank you.
The object across the analysis of problem formal theory based the analysis of problem. I think we is full and clear, and we have good results come from theory. And team B, I think your theory is full and clear also. And besides the fact that problem is complex, the process is simple. The agriculture error is good, and the material peak is good. Just a good energy. Explain for phenomenon and prevent the parameter is good. Thank you.
Okay. Now let's have questions from the jury member. Any question? Yes.
So I have practically the same questions for both team A and team B. So I will first start with team A. So when you show the results about the cook degree or the maturity degree, so you show that you have three different regions. So one is below, roughly below 3, and between 3 and 6.4, and then above, so 3 between 3 and 4, and above 4. So I want to ask is that what is the maximum of your maturity? Is 1 or is 2 or 3 or something? That is first part of the question. So in the first horizontal row, so you have the maturity, 0 to 0.3, 0.36, 0.36 to 0.4, and larger than 0.4. And what is the maximum of your maturity degree? Maturity, 1 or 2 or 3?
It's 1.
It's 1. Okay. And secondly, so for your method, can you really so identify the difference between, for example, so 0.2 and 0.3. So the maturity 0.2 and 0.3. Can you really separate these two eggs, these two kind of eggs?
0.2 and 0.3 is very close. So we can in our experiment we can identify it clearly.
Okay, particle is also roughly the same question for team B. So in your optical methods, so you separate between the 39 degree and 85 degree, if I remember correctly.
Yeah.
And you separate this into 100 degrees.
Yes.
So, yeah, that's roughly the same question. Can you really separate the 80% cooked egg and 81% cooked egg? So if not, so how do you think you should adjust your separation? For example, you know the temperature, and you now separate into 100 segments. How do you wish to change?
Yes,
So,
it's about our error analysis, right? Because every egg has its individual character, right?
not exactly. So what I mean is, if you cannot distinguish, you cannot see the difference between 80 degree cooked and 81 degree cooked, then maybe you should change your sensitivity. For example, you separate to 100, and then how do you wish to separate, for example?
My degree is to late, right?
Well, I don't know. So can you really see the difference between?
In fact, when we read log L by 0, we can tell this is 89 and this is 80. But because we have brought the character of the egg, it's not that exactly, because unless you use of course the same egg when we deafen or cook the degree and use the same water and everything is the same, it may be the same, but all we can roughly tell is 81 centigrade, it's 81 cooked degree and or 80 cooked degree. There is much it's not that exact, but much more exact than.
How do you wish to change your scale? So you have all this.
Yeah, and you can hear we have things that as you can see, we can roll. We can see if we guess the log L by 0 is between here. It might be it may be 1 cooked degree, and between here the second, and we can do that, but we just give this formula. It can show about the approximate. Yeah, it's not that exact because it's actual correct.
Any other question from other jury members?
I have a question.
Yeah.
Team B, you mentioned that Team A use the put energy is uniform, right? In your summary. Oh, sorry. Sorry, mistake. Team A, yeah. You mentioned that Team B, when they do their experiment, you said that they use put energy in your summary. You can summary.
Your conclusion.
Oh,
Is it our miss our
Should show the page.
no, this.
this we
Hey, no, next.
we put,
Yeah.
put the
Next.
we put the wrong PowerPoint. We put the wrong page. Sorry.
Okay.
Okay, thank you.
Any other question? So I have a question for Team B. So you use the temperature in the center to represent the how well it is cooked, right? But we know that the phase transition actually occurs not in 100 degrees, but at, say 70 degrees. But you are putting the egg in a 100-degree environment, and we know eventually the center will reach 100 degrees. Right? So do you think this is a reasonable index to characterize the cooking method?
I think if I get the part, ask me about that the different eggs may have same phase transition distribution when its temperature is different.
No. I mean the core temperature
Yeah.
eventually will goes to 100 degrees,
Yeah.
right? If you put it in boiled water long
Yeah.
enough. But the phase transition or how well the egg is cooked depend on the phase transition of the protein, right? But the phase transition occurred
Yeah.
actually not at 100 degrees,
It-
right? It occurred at like 70 degrees.
After 80 centigrades, all of the proteins will start to phase transit and keep boiling when the core temperature is still going up. It requires enough time for all of our fats and proteins to complete the phase transition. As you can see, it only requires about 20 seconds to the phase for 99% protein to complete the reaction. And so when the core temperature reaches 100 centigrades, even the proteins in the core can complete the reaction.
Yeah, but I mean, you probably shouldn't use the 100 degree, right?
100.
Basically, as long as the core temperature reach 85,
Yeah.
as you said, the phase transition is
It's almost already. Yeah. We use 85 centigrades to cook the degree 100. It means fully cooked.
okay.
And 39 centigrades, we use this as the cook zero because you just not cook it, put it into the water of 39 centigrades. It will finally change into a chicken. Yeah. 38 centigrades to 40 centigrades, so we use 39 centigrades. Yeah.
But most of the eggs that we ate actually do not hatch. Okay, thank for posting. Go to the grading session. Ready? Okay, so for team A, starting from me,
What's
6.
A? This is A.
Yeah, this is A, sorry. So 6, 6, 7, and 8.
Thank you.
Okay, now let's go to team B. 8, 8, 8, and 8. Okay, so any other comments from the jury member? No? Then, yeah.
So I haven't, maybe I think you shouldn't give up the method of rotation. Yeah. Because rotation is a common method for this question.
Yeah, tradition.
And you have a linear line in the rotation method, but you give up it. Maybe I think you can research it.
Yeah, we do lots of experiments, but it's always a mess. We don't know. We have divided. We have used its volume or its mass to divide the damping coefficient or the moment of inertia, but it doesn't help me. So I don't know what to do. Yes, thank you.
I think I would like to comment on my question. So basically, both teams you have the scales, but you have to pay attention that when you measure and your data point might aggregate at some parts, which means that if you separate into 100, it is not sensitive enough. It is so our experiment is not that sensitive, so you should change to maybe just separate into 10 parts, and then you will have your method will have better sensitivity. Or on the other hand, this is your sensitivity.
Okay, so let's end this session.